This is a video on the pre-lab of our decomposition of baking soda. So in this lab, we're looking at a substance called baking soda, which you probably have seen before, maybe in your kitchen or in your fridge. Baking soda has a chemical name that we use in chemistry, and it's sodium bicarbonate. And it also has a formula of NaHCO3. HCO3 is a polyatomic ion called bicarbonate. And sodium is seen here as a symbol Na. Na has a charge of +1, HCO3 has a polyatomic ion charge of -1, so together they make NaHCO3. And if you were to look at your baking soda that you use, and you were to look at the active ingredients, you notice here the pure ingredient is sodium bicarbonate, if you were to actually zoom in and see that. All right, so if you haven't seen this before, you might remember lab safety, where we've used baking soda as a base to neutralize our acid spill. Well, we're not doing that today in lab. Instead, we're going to take baking soda and we're going to decompose it, right? So we're going to break it down. And the question is that when baking soda decomposes, what products do we make? So that's the question. When I decompose NaHCO3, what do I get? And so your two options that are going to be given to you on your actual lab are these two. Does A happen? When NaHCO3 decomposes, do you get Na2O, CO2, and H2O? Or does B happen? Do you get Na2CO3 plus CO2 and H2O? So if you notice in these equations, for sure I get carbon dioxide gas and water vapor, right? That's given in both of them. But the real issue is which solid gets produced. Is it the Na2O or the CO3? So which one gets produced is really what I'm looking at here. And so in this lab, we need to take our sodium bicarbonate and we need to decompose it. So that requires us to heat it up. So we're going to need a ring stand, a ring, and wire gauze, seen here, set up like this. We're going to need an evaporating dish, seen here, and our Bunsen burner, our striker, our hot hands, our crucible tongs are all going to be extremely helpful, obviously, as well as our sodium bicarbonate. So in this lab, some important safety things and setup features that you want to remember is that your Bunsen burner needs to have two cones, an inner and an outer cone. Remember, the inner cone, the tip of the inner cone, is the hottest flame. So the way we adjust our Bunsen burners is through our barrel, seen here. You're going to either turn it all the way to the right, or a little bit to the right, or a little bit to the left. You don't want to completely unscrew it because then it could fall off. Also, on some of your Bunsen burners, you might see these little vents down here. These vents let in oxygen. So if you have too much oxygen coming in, that could be interfering. But if they're completely shut and you don't have any oxygen coming in, then that would be bad. So you want to make sure they're slightly open. You don't want to touch any other features on your Bunsen burner. So adjusting the barrel helps you get the two cones, inner and outer. Okay? You want to make sure that when your Bunsen burner is lit and placed under here, that the bottom of the evaporating dish, right, is touching the inner blue cone to get the hottest heat. So that might require you to first light your Bunsen burner, right, using your striker. And again, to use my striker, I want to push this back and across my striking pad here. So I'm going to take that flint, right, that's a flint, and strike it back and across to make a spark to spark this. As soon as I have my flame, remember adjusting it. Okay. Now, here's the hard part. You might put this under here and realize my setup here, we'll pretend, is way too high, and so it's going to take forever. So how do I adjust that? Well, remember, the minute your heat is on, your metal will get hot. So what you need to do is you need to turn your Bunsen burner off and remove it. Remember, at any point you can move your Bunsen burner around like this. And you need to adjust this. So first things first, you want to remove your evaporating dish. Make sure you have a secure hold before you actually move your setup. See here? I can move my setup with two hot hands, right? Undo the screw on the side, move it up or down to whatever level I want it to be. securely fasten it, re-put the evaporating dish back on. Okay, good. I don't want to break anything. I don't want to move this with an evaporating dish on, right? Relight my Bunsen burner here, then place it underneath and say, yep, that looks good. All right, so that's what the setup is all about. So once the setup is done and you're heating it, some things you want to make sure you take into consideration are your observations. You want to make sure you look closely. And when your actual baking soda decomposes, you actually won't see a huge change. So you're not going to see like your white powder turn green or tons of gas come off or smoke. So you have to be careful and follow the procedure and see what the recommended time of heating is. But then if you look closely, right, when the flame is off at your final product, you'll see a slight change in the composition, okay? Remember, some other helpful things is that you're going to be asked to weigh your evaporating dish before you begin, and then you're going to be asked to weigh it once you've put your sodium bicarbonate in. And if you want just your starting amount of sodium bicarbonate, then you'll take the mass of your evaporating dish and subtract it out of the evaporating dish plus the sodium bicarbonate. So just a reminder about how to do that. Two words that you're going to be introduced to in this lab are actual yield and theoretical yield. Actual yield is what you, the experimenter, you personally, what you get in lab as your final amount. So when you're done decomposing this, how much of the product you make. Now remember, you're human, so you're going to have some error. And that's okay, but you want to try to reduce that error. So the amount that you get in lab is the actual yield. Now, theoretical yield is the real amount that you should have gotten if you were perfect. So in a perfect world, you should have gotten this specific amount. It's the real answer. But again, in lab, what you get is the actual because it has some error in it. So if we were to look at a quick example and say, I plant 10 tomato seeds in the ground. And so I should theoretically yield 10 tomatoes. But, some of the seeds were defected or some of them were eaten. So I only got 5 tomatoes. So that's my actual yield. I actually yielded. Remember, yield in chemistry means to produce. So that's exactly what you're going to produce is an actual yield versus theoretical. Now these are important because you're going to take your actual yield, right, what you produced, your amount, and you're going to compare it against what theoretically should have been yielded to figure out which of the two reactions it is. And in doing so, you're going to need stoichiometry to do that. So your lab questions will set you up and help you solve that. All right, that's the end of the video. Your decomposed baking soda can go into the garbage. Remember, all the equipment can be found either in your drawer or in the back of the room, as well as your ring stands, which can be also found either in your drawer or on the side of the room as well.